Alright, so far we have found the volume of a region using the disk method and the washer method, and those are about both around a horizontal axis. Today we'll be looking at finding the volume of a solid of revolution made by revolving a region around a line using the shell method. Okay, the shell method we will always use for a vertical axis of revolution. So if it's not horizontal, the disk washer method will not work, or it's not the most convenient method. Basically what we're going to be doing, I want you to think of if we're going to use the shell method, I'm going to kind of use a figure that hopefully you're somewhat familiar with. Let's say I take a cylinder, and actually the cylinder that I'm going to be concerned about this morning is, let's say I have a Swiss cake roll. And if you can envision what a Swiss cake roll looks like, there's a hard chocolate layer on the outside, and then right inside of that there's a chocolate cake layer, and then there's a white cream layer, and then back to the cake layer, and then the cream layer. So there's all sorts of layers, and we're going to think of those as shells. And basically what we're going to be doing is we're going to be finding the volumes of each of those little layers. So we'll find the volume of that hard chocolate layer, and then the spongy cake layer, and then the creamy layer, and then what we're going to be doing is adding them all together. We of course will let the integral do that for us. Okay, to get the volume of each one of those layers, just how we did with washers, we took one area, subtracting the other one. That's exactly what we're going to do for this one. We'll basically be taking the volume of the cylinder, we'll take the volume of the outside minus the volume of the inside to get each one of those layers. Okay, without going through all of the math of that, after you've gone through all the math of that, you will end up with this formula right here, which says volume equals 2 pi, going from the integral from a to b, p of x, h of x. P of x is the radius of the shell. And if you'll notice, I just drew a picture, so if we've got a figure that looks something like this, the P of x is this radius, and it's basically just the distance from the axis of revolution over to the one of the layers that I'm going to. Okay, this number is usually just x, and the reason that it's usually just x is because this would be x units away from that axis. Okay, we'll do a couple where we actually revolve it and it's a little bit differently, but for the most part it's just x. Okay, the next part, the h of x, is just the height of our shell, and the way that we'll get the height of our shell, we'll take the top minus the bottom. That will create, so notice if I want the height of that shell, we just take the top curve minus the bottom curve, and that gives me the height. So let's go ahead and see if we can do some problems. Okay, first one, it says to find the volume of the solid of revolution formed by revolving the region bounded by the graphs of y equals 8, x equals 0, y equals 0, x equals 2 about the y-axis. So first of all, we will always start by drawing a picture. We've got y equals 8, we've got x equals 0, we've got y equals 0, and then we've got x equals 2. And you'll notice this would be the region that we're talking about. We're going to revolve it this time about the y-axis. So if I rotate it this way, we'll get something that mirrors it over on the other side. And if I turned it into 3D, we've got our Swiss cake roll. So that's what we're going to be taking the volume of. And you'll notice it's a cylinder. We could really take this without calculus, but we're definitely going to use calculus for this one instead. Okay, up above, I'm going to go ahead and put the shell method. It was 2 pi. It's going to go from a to b, and we have p of x, h of x, dx. Right, so I'm going to have volume equals 2 pi. The x value it will go to is from 0 to 2, so we'll go 0 to 2. And then p of x, the distance from, so I'm just going to draw, like let's say I'm just trying to find this layer right here. The distance from the axis over to that layer is just x, so we'll just put an x there. And then to get the height, it's just the top minus the bottom. So the top is the line y equals 8, and the bottom is the line y equals 0, so 8 minus 0. dx. Okay, and we'll go ahead and do this one non-calculator. So we'll have 2 pi. If I just simplify that a little bit, I'll just be left with 8x dx. And then from here, if I take the integral of that, I'll get 4x squared, and I'm just going to let that 2 pi hang out there till I'm all the way done. I'll get to evaluate it at 2 and 0. If I evaluate it at 2, I'll get 16. If I evaluate it at 0, I'll get 0. So I'll get 16, and then I do have my 2 pi hanging on still, so 2 pi times 16 will be 32 pi, so that will be my volume. Okay, question 2. Find the volume of the solid of revolution formed by revolving the region bounded by the graphs given about the y-axis. So if you want to get your calculator out and just rejoin me when you're done, that would be great. It's going to look something like that. And then that's the first curve. Then we have y equals 0 and x equals 0. So it's going to be this part right here. And it's just going to stop right at the y-axis, and I'm revolving it about the y-axis, so it's going to kind of mirror over on the other side. And if you're thinking, boy, what does that look like? It's got a flat bottom, then it kind of goes down in the middle. If you're familiar with what a Werther's looks like, it kind of dips down like that in the middle, so that's what we're going to call it, Werther's. Alrighty, so since it's going about the y-axis, we get to use the shell method. So 2 pi, and then remember it's going to be p of x, h of x. So I'm going to have volume equals 2 pi. This is going to go from 0 to where this touches the x-axis. And on this one, if I want to find out where it touches the x-axis, I can just do the 0 feature of my calculator. And if I do the 0 feature of my calculator, that's going to be 1.61803. Notice I went out 5 places instead of just 3, and it will start at 0. And then my p of x, again, if I just drew one of my layers that I want to find the volume of, the distance from the axis over to there is just x units once again. So we're just going to put in x. And then the height, if I look at the top of this layer, the top is formed by the curve x minus 1/2 x cubed minus, or plus 1/2, excuse me, and then minus the bottom of that shape is the line y equals 0. Okay, then from here we are all set to go. I am going to go ahead and do this calculator, so from here we can go ahead and do math 9, and if you want to try that, go right ahead and then rejoin me when you're done. You should get an answer of 6.016, and that will be the answer. Okay, problem 3. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 about the y-axis. So first thing again we want to do is draw our picture. Y equals x squared plus 1 looks like that. Y equals 0 goes this way, x equals 0 goes this way, and x equals 1 goes this way. So we are going to have that shape, and then we're going to revolve it about the y-axis. I'm always concerned, make sure you draw your 2-dimensional shape. If you draw a 3-dimensional, it's up to you. If I revolve it about the y-axis, it's going to kind of mirror over on that side, and we're going to get again one of those glass type shapes that we did when we revolved about the x-axis. So we don't care this time that there's a hole or a gap. We're just going to, since it's y-axis, we get to use the shell method. So again, the shell method is 2 pi p of x h of x. Okay, so we're going to get volume equals 2 pi. This is going to go from x equals 0 to x equals 1. So 0 to 1. My p of x, so again, if I draw one of those layers, it just starts at 0 and goes out to x. So that didn't mean to, just goes out x in that direction, so x. And then the height is going to be the top minus the bottom. The top is hitting the line y equals x squared plus 1. And then the bottom is hitting the line y equals 0. And on this one, let's do it non-calculator. How about? So we're going to have 2 pi. I'm going to distribute, so I'll get x cubed plus x. And then the biggest thing on this one is since there's a plus sign, we can take the integral of each part separately. I'm going to let the 2 pi just hang out there till I'm done. The integral of x cubed would be 1/4 x to the 4th. The integral of x would be 1/2 x squared. I get to evaluate it at 1 and 0. So if I plug in 1, again, I'm just going to let my 2 pi hang out there. If I plug in 1, I'll get 1/4. Plus, if I plug in there, I'll get 1/2. And then minus, if I plug in 0, this time I will again get 0. 1/4 plus 1/2. Let me get a common denominator here. That would be 3/4. And then I can't forget that I had my 2 pi hanging out there. So 3/4 times 2 pi will be 3/2 pi. All right, example 4. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals x cubed plus x plus 1, y equals 1, and x equals 1 about the line x equals 2. Notice I changed it up on you. Let's see how that's going to change my answer. All right, y equals x cubed plus x plus 1 is going to look something like that. And then we've got y equals 1. which goes right there, I believe. And then we've got x equals 1, which goes right here. So the shape that's in question is this one right here. And we're going to revolve it about the line x equals 2. So here's my revolving line. So that's actually going to get mirrored over on this side. And if I had to think of a shape that would be, I guess it would be like a Hershey Kiss with the hole in the middle. So again, since it's about a vertical axis, we are going to use the shell method. So volume equals 2 pi, and then p of x, h of x. dx. All right, so we've got volume equals 2 pi. It's going to go from 0 to 1. So 0 to 1. My p of x is going to be, this is where it's going to change a little bit. When I go to figure out where it's going to go from, if I put a little layer in there, so let's say I put my layer right there, the p of x is always the radius, which is the distance from the axis over to that layer. Okay, to figure that out this time, I know that the distance from the y-axis over to that layer is x, and this whole thing is 2. So to figure out what this part would be, it would just be 2 minus x. So we're going to have 2 minus x, and notice that's where it's not just x. And then h of x is still the same. It's just going to be the top minus the bottom. The top is the curve x cubed plus x plus 1, minus the bottom this time is going to be the line y equals 1. And if you want to clean that up a little bit, you can. I'm going to go ahead and use my calculator to get the answer, so I'm not really going to clean it up at all. And then when I get that answer, I get 6.074. All right, let's try one more. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared, y equals 4x minus x squared, and the line about the line x equals 3. So if we go ahead and graph this, we're going to have y equals x squared and 4x minus x squared, which is going to look like that. So it's this shape right here. I'm revolving it about the line x equals 3. So it's going to get something, if we want to just do 3D, I have absolutely no idea what this shape would be, but we just might want to find it anyway. All right, since it's about a vertical axis, I'm going to use the shell method once again. So 2 pi p of x, h of x. Okay, again, my p of x, if I drew one of my layers, is the distance from the axis of revolution over to the layer. And again, this distance would be x. The whole thing is 3. So this one would be 3 minus x. So notice, hopefully you're noticing the last one was x equals 2. It was 2 minus x. This one is x equals 3. It's 3 minus x for the radius. Okay, this is going to go from where they intersect to where they intersect. And if I'm looking for where they intersect, for sure it's going to start at 0. And then we could either set those two equal to each other, which I think I will do since I haven't done that yet this section. I'm going to subtract x squared from both sides, so I'll get 0 equals 4x minus 2x squared, and then I'll factor out a 2x, so you get 2 minus x, and so x will equal 0, and x will equal 2. So it's going to go from 0 to 2, and then the height will just be, again, top minus bottom. The curve that's on top for this specific region will be 4x minus x squared, and then the curve that will be on the bottom is the curve x squared. Okay, and then from here, whoops, need my 2 pi out front. From here, we will go ahead and let our calculator do the work, and if I do that, we should get 33.510 as our answer. So hopefully now you can find the area or the volume of a region using the shell method.